All right, hi everyone. Today we're doing absolute value equations. So with absolute value, you've seen this a little bit back in our first unit with evaluating functions. We're really kind of dive into what it means to be absolute value and do quite a few examples today. What is absolute value? So absolute value is actually the distance a number is away from zero. And one big thing here is distance is always measured as a positive. What I mean by that is, like, if I said, like, I went for a run, I wouldn't say I went for, like, a negative 3 mile run. That doesn't really make sense to us. We always measure distance as a positive value. Again, we don't measure distance as, like, negatives. Like, the trip is negative 500 miles away from here or something like that. That doesn't make sense. We always do it as positives. That's what absolute value is, the positive. So this is what I mean by this. If I draw a little number line here for you. All right, if I said the absolute value of negative 3, what that's asking is how far away from negative or from 0 is negative 3. So I would say it's 1, 2, 3. It's 3 away from it. If I ask what's the absolute value of positive 3, very similarly, it's 1, 2, 3 away. So you'll notice when we do absolute value, you could have two different things go within the absolute value like brackets there, and they get you the same exact result. All right, so there's always two ways to get a distance here. There's the negative way and the positive way. So what that means is when we do problems like absolute value, we're going to have two different equations because we're going to have the positive value or the negative value, because if we plug in either of those to absolute value, you're going to get the same output. So what that means, if I give you a problem like this, the absolute value of x equals 4. Well, we should have two different solutions. One solution I could be is, well, I could just plug in 4 there, and I'll get positive 4 again. What would your other solution be? Your other solution would be the negative 4. Because I plugged in negative 4 into the absolute value, that you're going to get that same exact output. So we have two solutions. So all the problems we do today are going to have two solutions. Or we'll be looking for two solutions. So let's do an example here. Our first example says the absolute value of x minus 2 equals 6. So when we're doing these problems, you first want to make sure the absolute value is all by itself on that side of the equation. So if you look at the left-hand side, do you agree that the absolute value is all by itself? Awesome. You also want to make sure that it's always equal to a positive, because can an absolute value equal a negative? No. So you notice we have 6, that's okay. That's a positive value. All right, so what we're going to do is, once that is by itself, we're going to break this up into two equations. The first equation is just what it looks like. X minus 2 equals 6. Okay? Because essentially what I'm going to do is, if I want to know what that x minus 2 value is, to get me a positive 6, all right? Because if I put in 6 there, the output's going to be 6. All right, I could also put in a negative 6 into that absolute value and get that exact same result. So that's your second equation. X minus 2 equals negative 6. So I plugged in a negative 6 to those absolute values. You're going to get that exact same result. So we're going to go ahead and solve this. I would add 2 to both sides for this one. So I get x equals 8. I'm going to add 2 to this side, and I get x equals negative 4. Here's what I mean by that. If I check my answer, if I check this 8 first, okay, if I plug in 8 there, I have absolute value of 8 minus 2 equals 6. Let's see, 8 minus 2 is in fact 6, and the absolute value of 6 is 6. I could also check my second answer, that x equals negative 4. I plug in negative 4 minus 2. Negative 4 minus 2 is negative 6, and the absolute value of negative 6 is 6. So they both work. So both of these would be my solution. Because again, you're looking for values, the positive value that you plugged into that equation and the negative value that you plugged in, make it true. let's do another equation here. It says the absolute value of 2x plus 6 plus 4 equals 1. So step 1 is the absolute value all by itself. In this instance, it's not. We have that plus 4 on the side, so we need to subtract that plus 4 over. So you have to get it by itself before you start. So I have the absolute value of 2x plus 6 is equal to negative 3. The second thing is, we're going to pause here because something's wrong. It says the absolute value is equal to negative 3. Can you ever have the absolute value equaling an actual negative number? No, all right? It has to equal a positive because it's a positive thing that you're looking for the positive distance there. So I would say this is actually a no solution. Okay? The absolute value cannot equal a negative. So if you want to make a little star there, the absolute value cannot equal a negative. The absolute value is always going to be a positive value by the end. All right. Example 3 here. It says 2 times the absolute value of 2x plus 5 equals negative 6x. So first off, is the absolute value all by itself? I would say no. You have this 2 on the outside here. So we got to get rid of that first. Now you cannot distribute this through the absolute value. The absolute value is not like a parenthesis. So I would divide both sides by 2. Get the absolute value of 2x plus 5 equals negative 3x. Now you see, does it equal a positive? Now right now it says a negative 3x, but could we make that into a positive somehow? We could. If you think about it, if I plugged in a negative value there, it's probably going to be a positive. So this is the instance that it is okay. We're actually going to have solutions here. So we're going to continue on. So now that we have this, we're going to split it up into our 2 equations. The first one is going to be just what you see. 2x plus 5 equals to negative 3x. The second one is 2x plus 5. And you're going to change the sign of the second side there. So it'd be positive 3x. And what we're going to do is we're going to solve. All right, so I would say I'm going to subtract the 2x over here. So I get 5 equals negative 2x. Oops, sorry, not negative 2. Negative 5x. I'm going to divide both sides by negative 5, so I get negative 1 is equal to x. Over here, I'm going to subtract the 2x, so I get 5 equals x. So I have my 2 options here, but I need to check it. I need to plug it back in to see if it actually works. When you do this, you're going to plug it back into the original equation. By original, I mean the very first one you start off with here. So it says 2 times 2x. The first one we're trying is the negative 1 plus 5 equals negative 6 times negative 1. All right, if I do this inside here, 2 times negative 1 is negative 2. Negative 2 plus 5 is 3. Over here you get positive 6. The absolute value of 3 is just 3. 2 times 3 is 6. And so that is a true statement. So I would say yes, x equals negative 1 is going to work for us. Now we're going to try that 5. So same idea, we're going to plug it in. We have 2 times 5, which is 10. 10 plus 5 is 15. Negative 6 times 5 is negative 30. The absolute value of 15 would just be 15. I have 2 times 15 is positive 30, equaling negative 30. Is that true? Oh, goodness. What did I just do? There we go. No, this is not true. So this one would not be a solution. We would call this x equals 5. This is what we call as an extraneous solution. All right, so on your work, I would want you to have both answers down. I would want you to write extraneous solution. I do shorthand this too. EXT extraneous. So if you just write that, that would be fine as well. And here's the reason why this works. If you look right here, the step, we could have stopped right after here. Right after when we see that it equals a negative 30 here, can the absolute value equation equal a negative? No. So right away we knew that one wasn't going to work. All right. So again, you can have extraneous solutions sometimes, and you will only have extraneous solutions when you have an x on the side of the equation to start off with. All right, come to questions with class, or come to class with questions, guys. I'll see you in a little bit.